Before we look at quicksort, I want to remind you that merge sort had to make copies of array. So it couldn't do it in place or using that existing array. Quicksort's going to be able to do that, but let me remind you of merge sort. Remember, the first thing we did was we're like, oh, this is not in my base case. It's too much work. Let me divide it up, and I'll make copies of the first half of the array, and I'll make a copy of the second half of the array, and I'll recursively call merge sort on each of those halves. You can imagine that calling merge sort on each of those halves would lead to those ending up sorted. I'm not showing the recursive steps, but you can imagine they end up sorted. And then what I'm able to do is I'm able to do my merge operation to move things into the right spot. So I had these copies of the array. That's the big idea. Which one's smaller? The 10. Which one's smaller? The 11. Which one's smaller? The 12. Which one's smaller? The 16. Which one's smaller? The 17. Which one's smaller? The 18. Which one's smaller? The 19. Which one's, oh, none left. The 20. And so we ended up with that sorted array. But it required that we make those extra arrays at each step, okay? And quicksort is going to be able to do things in place, and that's going to add a little bit of complexity for us. Okay, now we're going to talk about how quicksort is in place and how it's going to work. And I'm going to use two indice variables. I'm going to use a turtle variable. This is going to be where I put my hypothesis of the thing one after where I think my pivot is. So I think my pivot is this one, and I'm actually going to choose the element that's at index 0 to be my pivot. And this little turtle is going to keep track of where is one after where I think the pivot should be. And then I have my duck, which is just going to be my looping variable, and it's going to go through every element in the array. Okay, so I'm going to start them off both at index, I don't think I can stack those. I start them off both at index 1. Now my looping variable is going to just loop through each of the elements. And the key idea is it's going to start and it's going to say, yo, are you smaller than the pivot value? If you're smaller than the pivot value, then I'm going to do something. I'll come back to that. But if you're not smaller than the pivot value, I'm going to keep going. So here I find that I'm not smaller than the pivot value, so I keep going. We can think about smaller than the pivot value as being like sort of on the wrong side of the pivot, on the wrong side of our pivot hypothesis. And so I'm able to walk through the whole thing, and I find actually, you know, I was right. The pivot value is one before the turtle, okay? And so in this case, that I didn't have to do any swaps, and that was the pivot. Now imagine we're in a scenario where my initial array was as shown here. I'm going to pick 2 as my pivot value. You can see already that there's one value that's in kind of the wrong spot. I'm going to start off my pivot hypothesis as right there. So my turtle starts at index 1. My duck also starts at index 1. And I'm going to walk my duck through until it finds a value that is smaller than the pivot index. Once it finds a value that is smaller than the pivot index, it is going to swap it at the elements at the duck index and the turtle index. So I'm going to swap those values. And then I'm going to update my hypothesis about where the pivot index should be. Now my hypothesis is that the pivot should be at index 1, sort of 1 before the turtle. And I'm going to keep walking my duck down until it finds another element that is smaller than the pivot value. It didn't find anything. And so now what I want to do is I want to swap my pivot, which I picked as at index 0, with 1 before the turtle. Remember, the turtle is my hypothesis of I put the turtle here, and my hypothesis is that the pivot should go 1 before it. So I swap the thing before the pivot value. Okay, now let's do an example where we're going to end up with 2 swaps. You can see I picked 3 as my pivot. So I'm picking the value at index 0 as my pivot. I start my hypothesis as saying I'll put the turtle at index 1 because my hypothesis is that that is the correct location for the pivot. And then I'll have my duck sort of walk along. When my duck finds an element that is smaller than the pivot, it is going to swap it. So nope. Okay, I found an index that is smaller than the pivot. So I'm going to swap the element at the turtle index and the duck index. And then I'm going to increase the duck index by 1. Okay, the duck is gonna increase the turtle index by 1. Sorry, I misspoke. The duck's gonna keep walking until it finds an element that is smaller than the pivot. Once it does, I'm gonna swap those 2 elements and update the turtle index 1 more. The duck is able to keep walking until we get to the end. And now what we need to do is we need to put the pivot in place. The turtle is 1 after where I think the pivot should go, and so I'm able to swap the pivot that I chose at index 0 with the spot 1 before the turtle. And then everything to the left of it is smaller than it, and everything to the right of it is equal to or greater than. Okay, let's walk through this another time. I'm gonna pick 40 as my pivot. I think that's convenient because then you can imagine all the 30s need to go to the left of it and all the 40s need to go to the right of it. So I expect to be able to put 40 at the exact right spot in the array after I run my pivot operation. So I start with my turtle. My turtle is my hypothesis of 1 after the real pivot. So right now I think that the pivot's gonna be at index 0, so I put the turtle 1 after that. And then my duck is gonna walk through each of the elements in my array. Okay, so what I'm gonna do is I'm gonna swap the elements if I find that the turtle, if the duck is referencing something that is smaller than the pivot. So not smaller, not smaller, not smaller. Oh, it is smaller. So I'm gonna swap the things at the duck and the turtle index, and I'm gonna increase the turtle index because I have a hypothesis now that the pivot should go right here. I'm gonna keep walking the duck until it finds something smaller than the pivot. It found something, so I'm gonna swap the duck and the turtle index. I'm gonna increase the turtle index because now my hypothesis is that the pivot should go right there. And I'm gonna keep walking the duck along. I found something smaller. I'm gonna swap the thing at the duck and the turtle index. And I'm going to increase the turtle index 1 because now my new hypothesis is that my pivot should go right there. And now the duck is done going through the array, and my turtle is 1 after where I think the pivot is, and so I'm going to put the pivot into place. And you can see everything to the left is smaller than it, and everything to the right is bigger than it. Okay, I think this next case might be a little bit surprising. So I'm gonna pick index 0 as my pivot. I'm gonna put my turtle at the hypothesis of 1 after where I think the pivot is. So my initial hypothesis is that the pivot should be right at index 0. And my duck is gonna walk through each of the elements of the array. Okay, I start off and I find that actually the duck is referencing something that is smaller than the pivot. And remember what I do in that scenario is I swap the values at the duck index and the turtle index, but they're the same. So like swap, and then remember the turtle index, whenever I do a swap, gets incremented. The duck keeps walking, it finds another value that is smaller than the pivot. So I'm going to swap the values at the 2 indices that I have. Okay, that is sort of a no operation. And then I update the turtle to be 1 more. The duck keeps walking. It finds something that's smaller than the pivot. So I'm going to swap the 2 elements at that index. Nothing happens again here because they're the same index. And whenever I swap something, I add 1 to the turtle index. The duck keeps walking through. It finds something smaller than the pivot. So I swap the values at those 2 indices, and I update the turtle. And then the duck keeps walking. It finds another thing that is smaller than the pivot. So I swap the 2 elements at that index. I update the turtle to be 1 more, and I keep walking. Now it finds something bigger than the pivot, so I don't have to swap. I find something smaller than the pivot, so I do need to swap those elements. And I update the turtle to be 1 more. Then duck goes to the last one. It's not smaller than the pivot. So we're done with duck now. And remember, my turtle is 1 after my hypothesis of where the pivot goes. So my hypothesis is the pivot goes there. So then I swap the pivot into place. And so I want to draw your attention to 2 things. One, there's the swapping that we do when we find the ducks at something that is smaller than the pivot, and we swap the values of these 2 elements. And then in the very end, I have 1 more additional swap, and that's the thing before the spot before the turtle index and index 0. I swap those ones to put the pivot into the right spot. And in my eventual sorted array, this is exactly where 40 is going to go, right? Here are all the numbers smaller than it. Here are the numbers equal to or greater than it. 40 is in the correct spot. That's really key. And can you imagine that I could treat this subarray as its own quicksort? I could do another pivot, this time using 33, and do sort of a similar thing that gets things all into the right place. So just like we reasoned with merge sort, here I'm going to be able to call quicksort on a subset of the array. That's going to end up getting sorted. I've already got 40 in place. I'm going to call quicksort on this subset of the array. Maybe that hits a base case because there's just 2 elements. That part's sorted. And using recursion, just like we use 2 recursive calls in merge sort, we're going to use 2 recursive calls in quicksort to be able to get the whole thing sorted. And where merge sort related to, calling sort on the first half and the second half, here we used a pivot. We were able to get that pivot in exactly the right spot in our array and then make recursive calls on a subset array of the array. And unlike merge sort, we didn't have to make copies of our arrays. We just were able to swap within place or sort of in place in that existing array.